Welcome to this Sahara 4 exercise. In this exercise, we will use the location analysis tool to review a number of locations predefined already that we have in an Excel file, and then we will use the same location analysis tool to create new locations and look for infill opportunities inside our project. So first we will go to our Excel file here, and here we have a number of locations, the name of the location, the x and y coordinates, and the datum. We will copy this information here, and now we will go to our Sara project. We will look for the tools menu here, and now go to location analysis. Once here, we will use this paste button here. That, as we can see, is going to copy the information from Excel directly to this table here. So here we can see that we have a number of neighbors close to the locations. For example, the well D42 is the only one that is close to to the location 2 and 3. The location number 1 is far away from any of the other wells, so it doesn't have any neighbor. And the location number 4 is close to these two, to the well D42 and to the well D31 that they are selected here. We can see here in the map the relative position of the new location compared to the nearby wells. And here we have finally the location number 5 that we see here, that is close to just north to D42 and D31, and also close to the well D89. So the search radius here is going to define how far is Sara going to look for these wells nearby to the position of the location to show them in the map. It will also define how many neighbors do we have, but it will also help with the definitions for the thickness calculation here. So for this thickness calculation, Sara will first try to take this thickness data from the map. In this case, we have different definition of thickness. We have net pay, net thickness, and gross thickness. Here we have a variable that has been created in this project before. So it's going to define the thickness that we need, in this case net thickness, and it's going to look for the data in the map for each layer. So if it has any information in any layer in any map, it will be summed here. So in this case, we have for 8 layers, we have a data of net thickness in the position of this location. So we have 8 maps that have data for this location. And the sum of the thickness of all these maps is going to be 57 feet of net thickness in total in all 8 layers. In the case that we don't have any map, or the map doesn't reach the position of the location, Sara will try to do another calculation with the nearby wells. It's going to use the petrophysical data of the nearby wells, if it has any petrophysical data for, in this case, net thickness or gross thickness or net pay, if they are the one that we want to do the calculation to. And it will, for example, inside this search radius is going to look for all the nearby wells. In this case, we see that we have 2 different neighbors. Is going to calculate based on the petrophysical data, in this case the net thickness that is stored in petrophysical data in D31 and the net thickness that is stored in petrophysical data in D42, and is going to be a weighted average of both of them, that is going to be weighted based on the distance. So in this case, the value of D31 is going to have a higher weight than the one coming from D42, because D31 is closer to L4. In the case of this, for example, of L5, or the location number 5, we can see that D42 and D31 are going to have similar weights. The petrophysical data of net thickness of both wells is going to be similar, and the one of D89 is going to have a smaller weight because it's farther away than these other 2 wells. So to recap, the calculation that is going to be done is first look for a map. If it has any data coming from a map, it's going to consider just that map data for net thickness in each different layer, and then it's going to do the sum. If it doesn't have any map available there, it's going to try to do the calculation with the petrophysical data that is defined in the different nearby wells based on this search radius here. If I increase this search radius, here we will be able to see that more wells will be included in the calculation, but obviously the weight that each one of them has is going to be higher for those that are nearby. Um, so yeah, that's the logic of the calculation of thickness and how a layer is that is in this case being drilled is defined that we have a layer in that location. In this case, we will go through 8 layers, 10 layers, and 9 layers, and the total sum of those layers will be 57, 64, 77, and 68 feet in each case of net thickness. In the case of the location number one, that as we can see is quite far away from the rest of the reservoir, is far in the southwest. Here we can see that we don't have any neighbor, so we don't have any map data for this location, which means that first, if we don't have any map data, Sahara is going to try to default to the petrophysical data calculation, but as it doesn't have any neighbor either, it won't be able to do the calculation, so we won't have any map information and we won't have any petrophysical data of the nearby wells information as well. So the total thickness is going to be 0 and the total layers that we are drilling through will be 0 as well. Finally, we can select these locations here to like approve them and click on close here, say wellbores. So now we have created 5 new objects, in this case 5 new locations. Remember that locations are different type of objects distinct from wells, and we will click OK here. And now we can check on the new locations by clicking on objects here, visible objects, and we will add locations, and the new locations are now plotted here. We have the 4 that are close to the wells that we were reviewing and the one L1 that is far in the southwest. I will select it so we can see the names, and we can also select them in groups here, and by clicking instead of well or all, we will just click on locations and we will select them all and see them in the map now. We can also review the new locations by going to edit, wells, data, and here we can select locations, and all the 5 locations will be selected with the X and Y coordinates. So yeah, and now we will go back. Now we have reviewed the locations that were already predefined, but now we will go back to the location analysis tool, and now we will look for new locations. In this case, as you can see, I have this button here, search for new locations. I will use the same search radius to define the nearby wells for the calculation of thickness, and now I will search for new locations. Here in the search of new locations, Sahara will do the triangulation to look for the new infills by trying to have a minimum distance to the nearby well and a maximum distance. So no location closer to any other object or any other well in this case will be created closer than 80 feet in this case, nor farther away than 1640 feet. Here we can define the location prefix, that in this case is going to be log, or we can define just L as the rest of the objects. And the coordinates we can define if the position that is going to be used for this minimum distance and maximum distance is going to be either the wellhead, the bottom hole, or the position of the layer we want to, or a certain layer. In this case, we can define the layer that is going to be used for the minimum and maximum distance calculation. This is obviously just going to apply in the case that we have surveys or like highly directional wells. If the wells are vertical, we won't care about the difference between wellhead and bottom hole or any other layer location of the survey. But this is important, for example, if we have a directional well and the only layer of interest is just one of them, and we can select it here, and the minimum maximum distance will only be considered for this layer. Again, we will just consider wellhead because all the wells in this project are vertical. So now we will click OK, and here we can select the options that will be used in the calculation, so in this case all of them. I will click OK, and now Sahara will look for new locations, and here we can see that we have plenty of different infills here we can see that each of them will cross a number of layers. It's going to drill through a number of layers if we decide to drill them, and they will have this thickness that, as we discussed, is going to depend either on the map if we have data, and if we don't have map data, it will be based on the petrophysical data with the weighted average that we discussed before. So here we have, for the wells that are nearby, the distance from the location, the current status of the well, the start date of production or injection, the time of the since the change of status, the total rate, oil rate, gas rate, water injected rate, net produced, like the total oil produced, gas produced, water injected in thousands of barrels, and the last water cut that we have available. So this is useful to review the nearby wells and have an idea of the productivity and the different data and information of the nearby wells to the location. Again, we can save them by clicking select here and then clicking save. So well, that will be everything for this tutorial. We have reviewed how to review locations that are already predefined, that have already been created before from an Excel file. We have discussed how to look for new locations, for new infill locations inside the project. So yeah, that will be everything for this tutorial. Thank you for watching and have a great day.